You've ever look at an old car or a bridge or maybe even your own bike and see that creeping reddish-brown rust? Yeah, it's everywhere. But have you ever really stopped to think about where it's winning the fight? Well, today we're going to dive into a pretty cool scientific race that pits different kinds of steel against two completely different environments. We're going to find out where metal decays the fastest and, more importantly, why. And trust me, the answer is not what you might think.
So this is the big question, right? You'd probably guess that a huge city, with all its pollution, all that grime and acid rain, would be an absolute nightmare for metal. But what if I told you that a quiet little town by the sea can be way, way more brutal? It doesn't seem to make sense. So what's really going on here? To figure out, let's meet the competitors in this great corrosion race.
All right, so you've got to know that not all steel is the same, not even close. The scientists behind this study picked three very different types to see how their unique defenses would hold up. Think of them like three fighters in a ring, each with a totally different strategy. Okay, first up, we've got carbon steel. This is the workhorse. It's the stuff that builds our world. Think buildings, bridges, cars, you name it. It's strong, it's affordable, but its defense mechanism is kind of weird. It basically fights rust by rusting. The idea is that a dense layer of rust forms on the surface and acts like a shield to protect the fresh steel underneath. A little counterintuitive, right? Next in the ring is galvanized steel. This is our workhorse, but with an upgrade. It's basically carbon steel that's been given a suit of armor, a coating of pure zinc. And here's the really cool part. That zinc layer is designed to be a sacrificial shield. It literally corrodes first, taking the hit to heroically protect the steel that's underneath it. And finally, we have our high-tech champion, stainless steel. This is the elite defender of the group. See, by mixing in chromium, stainless steel creates this incredible, microscopic, invisible shield on its surface. And here's the kicker. If you scratch that shield, it actually heals itself. I mean, come on, that is an unbelievably clever defense against rust.
So we have our three fighters. Now, where exactly are they going to battle it out? The researchers set up two identical arenas, both in Italy, to really push these materials to their absolute limits. Let's take a look at where this race is going down.
And here they are. Over on the left, you're looking at the urban arena, a rooftop right in the middle of bustling Milan. This is where our steel is going to face off against city pollutants. But on the right, that's the marine arena. It's a test rack in a coastal town called Bonassola, placed just 10 meters from the sea. You just can't get two more different environments. So, here's the most important part to understand, the invisible enemy in each location. In Milan, the main attacker is sulfur dioxide from urban pollution. But in Bonassola, the enemy is something else entirely. It's the airborne sea salt, those chlorides, that are constantly blanketing everything in this fine, corrosive mist. And that difference, well, it's the key to this whole story. So the steel samples just sat there for more than 2 years, 26 months. They were exposed to heat, cold, rain, and those unique invisible enemies. When the scientists finally collected the samples and analyzed the data, the outcome of this race wasn't just clear, it was a total knockout. And boom, here are the results for our workhorse, carbon steel. Just look at this. In the city, Milan, the steel rusted away at a rate of about 8 micrometers a year. That's considered a low corrosion environment. But then you look at the coast. In Bonassola, the corrosion rate just exploded to over 50 micrometers a year. That is more than 6 times faster, putting it in a high corrosion category. The sea was just absolutely brutal. Okay, but this is where it gets really fascinating. It's not just that the city's corrosion rate was lower. The data showed that over the 26 months, it actually started to slow down. How is that even possible? How can rust become protective? You see, in the city environment, the rust that forms is a specific, really dense kind of iron oxyhydroxide. As this layer builds up, it gets pretty stable, and it actually starts to act like a barrier. It basically shields the fresh steel underneath from the oxygen and water it needs to keep rusting. But at the seaside, those chlorides from the salt create a totally different kind of rust. It's flaky, it's weak, it's not protective at all, and it just keeps eating away at the metal. All right, so what about our shielded fighter, the galvanized steel? Surely its zinc armor did better, right? Well, yes and no. I mean, it performed way better than the plain carbon steel for sure, but the pattern, it was exactly the same. The corrosion rate by the sea was 3 times higher than in the city. That sacrificial shield was being sacrificed a whole lot faster next to the ocean.
And our elite defender, the stainless steel, well, even it wasn't totally immune. While it didn't have the same kind of dramatic metal loss as the others, the study points out that even the stainless steel developed superficial staining in the marine environment. It just goes to show how incredibly aggressive that salty sea air really is. Nothing gets away completely unscathed.
Don't just take my word for it. The researchers themselves summed it up perfectly. They state right here in the paper, and I'm quoting, higher corrosion rates were measured for samples exposed to a marine atmosphere with values belonging to exposure classes C4-C5 for both materials. So, high to very high. The science is just crystal clear. So you might be thinking, okay, a race between some metal plates in Italy, that's interesting, but why does it matter to me? Well, it matters a lot. Because these results have huge, real-world implications for everything we build. So what do we learn today? The single biggest takeaway is that airborne sea salt is the undisputed, undefeated champion of corrosion. It's way more destructive than city pollution. And that's because those chlorides in the salt do two terrible things. They make rust less protective, and they actually attract moisture from the air, keeping surfaces wet and ready to corrode. And this leads to the most important point of all. You have to use the right material for the environment. A bridge on the coast needs way more protection than one in the middle of the country. And getting that choice right, it's not just about saving money on repairs. When we're talking about critical infrastructure, it can literally save lives. This whole experiment gives us a really clear winner in the corrosion race. But it also leaves us with a much bigger question to chew on. Our environment, our climate, it's all changing. We're seeing more extreme weather, shifting coastlines. The arenas where we build our world are changing too. So the real challenge for the future isn't just about picking the right material off the shelf today. It's about inventing the new materials that can actually withstand the world of tomorrow.